Hello, my name is Stephanie McCulley, and I am the Purdue Extension Agriculture and Natural Resources Educator in Grant County. Today, I'm going to be touching on pond management, specifically aquatic vegetation. Every spring, I get many questions on weed management for lakes and ponds. Vegetation is an important part of any aquatic system, but sometimes it can get out of control and create problems. Today, we will discuss the benefits and difficulties of aquatic plants and algae, identify some common species, and talk about effective management strategies. Although many people want to reduce vegetation in a body of water, it's important to remember that aquatic plants are essential components of healthy aquatic systems. Remember, all plants, whether on land or in and around water, photosynthesize. A few benefits to aquatic vegetation are that larger algae and flowering plants provide habitat and shelter for fish food organisms, waterfowl, and other wildlife. Because all plants, including those that grow underwater, produce oxygen as they photosynthesize, they are major sources of oxygen for aquatic animal life. Rooted plants on edges of a pond or lake can stabilize shorelines and bottom sediments. They also absorb nutrients and filter pollutants from runoff, which can improve water quality. Because of these benefits, some aquatic plant growth is desirable, but completely eliminating native aquatic vegetation should never be the goal of a management plan. But still, there are times when aquatic vegetation can pose some problems. We know that plants growing in a body of water can quickly get out of hand. Certain invasive species can be very aggressive and can take over large areas of aquatic habitat. Excessive aquatic plant growth can lead to several common problems. An overabundance of aquatic plants and algae can reduce oxygen levels in the water, which can contribute to fish kills. Fish kills that are vegetation related usually occur in the summer or winter. Excessive plant growth can impede water flow in drainage ditches, irrigation canals, and culverts, and can cause water to back up. Excessive plant growth can also trap sediment and debris, which will gradually fill in bodies of water. When the plants die and fall to the bottom, this accelerates the process. Aquatic weed growth can provide the quiet water environment that is ideal for mosquito larvae to develop. Excessive plant growth will lessen aesthetic appeal and lower property values. Correct identification is very important so you are able to plan a successful course of action. The plants that commonly lead to most problems are algae and flowering plants. In the following slides, we will identify some of the most common species and how they can lead to problems if improperly managed. Pictured is microscopic algae or phytoplankton. This algae colors the water green or yellow-green. A phytoplankton population that colors the water is called a bloom. In quiet, still waters, blooms can produce surface scums as well as green, red, black, or even oily-looking streaks. Blooms occur in waters that have abundant nutrients. These nutrients often come from nitrogen and phosphorus fertilizers that reach the water. The best practice for managing blooms of microscopic algae is to prevent nutrient-laden water from entering the water body. Mat-forming algae does just that. It forms floating mat-like growths that usually begin around the edges and bottoms of bodies of water in the spring. Often incorrectly called moss, this type of algae growth is the most common problem in ponds. American pondweed is a rooted plant that will grow in shallow water, usually less than 4 to 5 feet in depth. The leaves are about 2 to 5 inches long, and the petiole is attached at the edge of the leaf. Note the long horizontal underground rhizome from which new plants are produced. Water lilies are also a rooted plant and grow in shallow water. Leaves float on the water's surface and are circular in shape. They are notched to the center and the leaf lobes are pointed. The leaves are on the top of long stalks that extend from long rhizomes in the mud. The flowers can range in color from yellow to pink or white. Effectively managing aquatic plants usually involves one or more of these management methods: mechanical, biological, habitat alteration, or chemical. Mechanical control methods involve removing plants manually, for example by hand pulling or raking plants. Since most aquatic plants are perennial, they have underground portions that can resprout new shoots, so it is important to harvest below ground growth. With larger plants such as cattails, this can be very difficult. Companies specializing in aquatic or fishery supplies do offer handheld devices for cutting or pulling plants in small areas. Biological control methods involve using beneficial organisms to control pests. The most widely used biological control agent is the grass carp. Grass carp consume most submersed plants. However, grass carp prefer certain plant species more than others, so they often consume native species such as pondweeds before feeding on the troublesome weeds such as mat-forming algae. Although grass carp can provide good aquatic vegetation control, it is not the solution for all ponds. Grass carp populations have the potential to strip a body of water of its underwater vegetation, so they must never be released in natural lakes and wetland areas where vegetation is critical to fish and wildlife. Remember to always check with the appropriate state regulatory or fish and game agency before releasing a biological control agent. Habitat alterations alter growing conditions to reduce aquatic plant growth. The primary targets of habitat alterations are nutrients, primarily nitrogen and phosphorus, and light. Adding aluminum sulfate or aerating a body of water can help reduce phosphorus concentrations. Altering light in an aquatic habitat is usually done with dyes. Dyes inhibit light penetration in the water by intercepting the light that underwater plants normally use for photosynthesis. Dyes can only be effective if the concentration is maintained, so do not apply a dye where water outflow will reduce its concentration. And lastly, chemical management. When properly applied, herbicides control aquatic vegetation without harming fish and wildlife. Before you choose or use any herbicides, there are a number of important considerations. First, properly identify the weed. Certain herbicides will only work on some weeds and not others. Never apply chemicals in or around water unless they are specifically labeled for aquatic use. Always read herbicide labels and apply the correct rate. Make timely applications. Late spring is usually the best time to apply aquatic herbicides. This is when plants are most susceptible because they are young and actively growing. Also apply when the temperature is right. Herbicides do not affect aquatic plants when the water is too cold. The areas to be treated should have water temperatures in the upper 60s. And lastly, know the difference between contact and translocated herbicides. Some herbicides work very quickly by killing the plant tissue that they contact, such as copper sulfate. Use these contact herbicides for spot treatments. Translocated herbicides work more slowly because they move into the plant through leaf tissue and give a more permanent kill than contact herbicides. Although we want our ponds and lakes to look clear and free of green because it is more pleasing to the eye, remember that some vegetation is essential to fish and wildlife. Remember what you learned today about the importance of aquatic vegetation and tips on how to properly manage as you get your pond ready for spring. If you have any questions, please reach out using my contact information on this slide. Thank you and have a great day.